In this video, we are going to cover the idea of repetition in Java, and in particular, we look at how to construct a for statement to repeat a block of code. There are many tasks in programming that require us to repeat a block of code, and in fact, many programs that produce extremely complex output are really only executing or repeating a single task, a simple task, many times. So, for example, if we want to repeat a message to the screen, if we want to repeat any block of code, we need to use the idea of repetition in Java. So to do that, we use the for statement, and the for statement is comprised really of four parts. It comprises of an initial state, a guard, some way to make progress, and then we have to have some kind of task to perform. So the syntax of the for statement then is, well, it requires a number of different parts. It requires an initial state, it requires a guard, it requires some way to make progress, and then it requires some task to complete. So we'll have a look at each of those parts of the for statement in this video and construct a very simple for statement to repeat a message to the screen a number of times. So the for statement, when you look at its various different parts, it uses a loop counter variable in the initial state, the guard, and the progress. So we need some kind of variable that's going to control the amount of times that our code is repeated, our task to complete is repeated. So this variable, you can call it anything you like, but in these examples I'm going to introduce an integer variable called j, and we're going to set that integer variable j to some value in the initial state. And then in the guard, we'll set some Boolean expression that will control the amount of times the task to complete is repeated. And then in the progress, we will make a change to the loop counter variable j that will ensure that we actually make progress and allow the loop to continue and increment j so that eventually j will be equal to 50, and the guard on the loop will break because j will no longer be less than 50, and at that point our loop will end. The task to complete in this example is just to output a simple message to the screen, so it's not going to do anything very complicated. So the guard on the loop is a critical part of this because that is going to control the amount of times the loop will repeat the task. So j less than 50 will ensure that this message is printed to the screen 50 times. J equal to 0 will be our initial state, and as I said, incrementing j equals j plus 1. That will happen every time around the loop as well, and it will ensure that j eventually reaches 50 and the loop will finish. So to construct our loop, we write for, and then we introduce our loop variable j. So I'm going to say int j equals 0. And then the guard on our loop is j less than 50 because we want to repeat the task 50 times. And to make progress, we say j equals j plus 1. The task to complete then becomes part of what we normally call the loop body, or as we're calling it in this case, task to complete. So in this example, I'm using these brackets here to define the loop body. So the loop body becomes this part of the code in between these two brackets. So that's going to be the piece of code that gets repeated. And effectively, the loop will continue to loop around as long as j is less than 50. So I'm just going to output a simple message here, say system.out.println, and I'm just going to say programming is cool. Okay, so when I execute this program, the loop will start off, it will initialize my loop counter variable to 0, so j will become equal to 0. The guard will be evaluated, so the guard will be checked, and we'll check to see if j is less than 50. And of course it will be the first time round because we set it to 0. And then the task to complete will be performed because the guard on the loop evaluated to true, j was indeed less than 50. So this piece of code will get executed, and then this piece of progress code will get executed. So j will be incremented, j will equal itself plus 1. So j will now equal 1 because it was 0. So it will be 0 plus 1 is 1. Now j will equal 1. We'll evaluate the guard again. 1 less than 50 evaluates to true. So we'll execute the loop body. And then we'll increment j again. So j is 1 this time, and it will be 1 plus 1 is 2. So 2 less than 50 will again evaluate to true. We will execute the loop body and increment j again. And we'll continue to do this as long as j is less than 50. So at some point in looping around here, j will eventually get incremented up until it is 50. And then we'll get to the point where it will be 50 less than 50, and that evaluates to false. When that happens, our loop will finish. We will no longer execute the loop body, and the program will just finish up here. So if there are any more statements after the loop, they'll get executed. So when the loop finishes, when this whole loop finishes, the program execution will end up at this point, and if there are any more statements, they'll get executed here. Okay, so we don't have anything after a loop, so once the loop finishes, our program will finish. So if I compile and run this, you'll see that we get the message programming is cool repeated to the screen 50 times. So it is 50 times, but how would I know that it's 50 times? Well, what I can do is during my printing of the message here, I can actually print out the value of the loop counter variable j in order to check the amount of times this piece of code has been repeated. So what I'm going to do is I'm going to, instead of using a println, I'm going to change this to a printf statement. And I'm going to use a placeholder for an integer value, which is %d. So that acts as a placeholder. And the message programming is cool, and the placeholder %d will be printed to the screen. And of course, where the placeholder is, it will be filled in by the value of j. So instead of seeing this symbol being printed to the screen, %d, it will take the value of the current value of the loop counter variable j, and it will place that here in my message. So now when I run the program, you'll see that I get this output. Programming is cool 0, programming is cool 1, but it looks a bit messy at the moment. So what I'm going to do is go back to my message, and as well as the placeholder here, I'm going to also include a \n. And what that will do is that will print a line feed, because \n is the line feed character, and that will print a new line in my output. So I should get my message and then followed by a new line. If I compile my program now, you'll see that I get programming is cool 0, 1, 2, 3, 4, 5, 6, and all the way up to 49. So why is it only going to 49? Well, remember, I'm starting at 0. So if I start at 0, and my loop counter does start at 0, j equal to 0, well, the first time round will be 0, followed by 1, followed by 2. So that will give me 50 repeats. That will give me 50 executions of the loop all the way up to 49. If I wanted those numbers to go from 1 to 50, including 50, what I could do is, instead of initializing j to 0, I could initialize j to 1. And then instead of saying less than or equal to 50, what I could do is say j less than or equal to 50. So now j will start at 1 and it will continue to be incremented as long as it is less than or equal to 50. If I execute the loop now, you'll see that my loop counter starts at 1 and it increments all the way up to 50. Now, have I executed the task more than 50 times? No, it's still only executing it 50 times, but I've just simply changed the initial value for j, and I've changed the guard on the loop to give me the numbers from 1 to 50. It's still executing the piece of code, the task to complete, 50 times. What about if I wanted to increase the number of repeats? Let's say I wanted to print that message 1,000 times. Well, I could just simply change the 50 here to 1,000, and that would repeat the task 1,000 times. So now when I execute my program, I'll see that I start at 1 and I go all the way up to 1,000. So the message is printed 1,000 times. And of course I'm verifying that and I'm checking that it is repeating it 1,000 times because I'm printing out the value of my loop counter variable j. So the value of j is being printed out in my message. Okay, of course I don't have to print a message. I could just get rid of this programming is cool bit and I could just print something like that. I could just use the placeholder and the line feed and the value of j, and if I do that, you'll see that I just get the numbers. I just get the numbers that I'm printing out. And where are these numbers coming from? Well, they are actually the loop counter variable j, the value of the loop counter variable j each time around the loop. And of course I get the numbers from 1 to 1,000 printed because I'm starting at 1, my guard is j less than 1,000, and I'm incrementing j by 1 each time around the loop. So it's important to remember that the for statement requires those 4 very important pieces: initial state, the guard, the progress, and the task to perform. We execute the initial state, we evaluate the guard, we execute the task to perform, and then carry out the code for making progress. And once that's done, then we repeat steps 2 to 4 as long as the guard is true. When the guard is false, then the loop will end, and if there are any more statements to execute after the loop, they will be executed. So we start off, we get our initial state, we evaluate the guard, we execute the task to perform if the guard evaluates to true, we make progress by incrementing j, and we re-evaluate the guard, and we continue around in that pattern until the guard evaluates to false, and when it does, the loop finishes execution. So it's very important then to remember that our loop needs an initial state, we need to define the guard, we need to make progress, and of course we need to specify a task to perform. Okay, so that is a very simple for statement and for loop in Java. All it does is print a message to the screen a number of times, and we can check the value of our loop counter variable j as we print out each message.